Hi, I am researcher Nai. Have you ever had the experience of your mind being in different states during different times of the day? For instance, you are in the mood of focusing on your work and meeting challenges during daytime, but prefer to getting relaxed and having a drink with your friends at night. Or just the opposite? It seems there are some routines our brains follow that switch between these states. In fact, it has been suggested that our brains do have different states, and will show brain waves of a certain frequency in each of these brain states. For example, the state of high anxiety, active engagement and external attention is linked with beta waves, 14 to 30 Hz. The state of high relaxation and passive attention is linked with alpha waves, 8 to 14 Hz. The state of deep relaxation and inward focus is linked to theta waves, 4 to 8 Hz, etc. But what exactly are brain waves? We know that the neural system works by transmission of electricity, and brain waves are oscillating levels of electric potential in neurons of the brain, measured in just a few millionths of a volt. It is believed that the various brain states we have through the day is the reason behind our changing mood or mode of behavior. As brain states are linked with brain waves of certain frequencies, then comes the question, could we enter a desirable brain state by somehow tuning our brain to a brain wave of a certain frequency, so that we can have the mood or mode of behavior we want? Well, you're welcome to the realm of neural entrainment, also known as brainwave entrainment, which refers to the observation that brain waves will naturally synchronize to the rhythm of periodic external stimuli, such as light, sound or tactile stimuli. So, theoretically, by applying an external stimulus of appropriate frequency to the brain, we should be able to tune the brain to the desirable brain wave and hence brain state. Here is an experiment that illustrates the use of neural entrainment. Researchers of this experiment first ran a resting state electroencephalography (EEG) measurement to detect the individualized brain rhythm for each participant, which is a frequency of alpha brain waves having the highest potential or amplitude, also called peak alpha frequency. Afterwards, for entrainment, a visual flicker light with flicker rate matching the individualized peak alpha frequency found was viewed for some time by each participant to induce individualized alpha brain waves. Then participants were asked to complete a visual discrimination task, identifying patterns with noises radial or concentric, and learned if they were correct or not. Such process was repeated for a number of times. To test the effect of entrainment under different conditions, participants were divided into 3 groups. Those in the peak match group, PM group, have flicker rate matched with their peak alpha frequencies and the visual discrimination tasks were presented at the peaks of the related alpha cycle. Those in the trough match group, TM group, matched with peak alpha frequencies and tasks at the troughs, while those in the trough non-match group, TNM group, plus or minus 1 Hz non-match with peak alpha frequencies and tasks at the troughs. The researchers found that individualized alpha entrainment with tasks presented at the trough phase accelerated learning, that is, individuals in the TM group showed the highest increase in correct percentage, C%, after completing a certain number of tasks, T, comparing with individuals in the PM and TNM groups. Further, to test whether the TM group showed improved learning compared to no entrainment, researchers assessed learning in a control group, C group, who underwent process identical with TM group except having flicker light with random interflash intervals. They found that the TM group also showed higher increase in correct percentage, while there is no difference between the C group and the other groups. To sum up, these results suggest that individualized alpha entrainment enhances learning, but only when materials are presented at the troughs rather than the peaks of the induced alpha brain waves. While it is encouraging that neural entrainment does produce the effects that we desire, the way entrainment is performed may need more attention. The brain provides some natural ways to receive stimuli through our sensory organs. But entrainment by conducting mild electric current through the brain or other direct neurostimulation means are also proposed. Given the brain may have some specific built-in protection for the natural ways, something like the blood vessel wall in the brain that can shield the brain from harmful substances in the blood which does not exist in other ways, will it be safer to take the natural ways? And how about the use of AI in entrainment? For example, will a frequency rather than the peak alpha frequency be predicted by some AI monitor that can better charge human potential through entrainment, given the data of personal biomonitoring? We just have to find out the answer. Thanks for watching. Looking forward to sharing more amazement in our next episode. Until then.